All right, last time we were working in 7.2, and we had left off on one example at the very end, example number 7. And we were talking in this example, kind of just discussing it before we left last time, about how it feels a little bit counterintuitive that we would take a number that's practically 1, and we'd raise it to the 10,000th and 10,000, right, place, to the number 10,000, and it would become practically 0, which feels sort of not right in some way. So we're going to do an example. If you have a calculator out, that's what you need in order to be able to really give a good idea about this. If you don't, just copy things along as we go. And I'd like for you to see how this ends up happening and why that's the case. And then we'll talk about how we would respond to the student. So I would like for you to start by considering just the number 0.999 squared. Okay, just square it. Take your calculator, square that, and somebody tell me what you get. We're going to record everything to 6 decimal places as we're working our way along, so that's what we're going with. I know, big numbers, but it's okay. So what is 0.999 squared? You can tell me, Annika?
0.998001.
Okay. So it's still almost 1, right? But it's smaller than it was before. Agreed? Okay. What we're going to do every time is we're going to double what we've done before. So what we're going to do essentially is raise this to the power of 4. So we're doubling the exponent every time. So we're going to go from 2 to 4, and then we're going to do 8 here in a minute, and then we're going to do 16. Okay? So what is this if I raise it to the power of 4? What'd you get, Ariel?
I got 0.996005996.
Okay, so with 6 decimals, it'd be 006. Okay? You good with that?
Oh.
For 6 decimals?
Oh, I didn't. I'm sorry.
I just stopped at 6. We have to stop somewhere, so I decided 6. Okay, again, it's still almost 1, but it's a little bit smaller, and it's a little bit smaller than the last calculation that we did. Okay, so let's double it again. So let's raise it to the 8th. Okay? So what happens when I do 0.999 to the 8th?
0.992028.
Okay, thank you, Sam. Did I get it written down right? Again, I mean, this is still 99 cents, almost $1, right, so to speak. Let's double it again. What about a power 16? 984119. Did I get it all?
Yes.
Okay. Okay, we're a little further away from the dollar, right? We're at 98-ish cents now instead of 99. But, I mean, we're still nowhere near 0. Agreed? And nowhere near. Let's double it again. So 32. Somebody who hasn't given me one, tell me what you see on yours, this one.
0.968491.
Okay. That was a bigger jump, didn't it? Bigger than we were making before. All right, double it again. 999 to the 64. Do you have it, Michaela?
0.937970.
Okay. Thankfully, that was a bigger jump because we're, Okay, there's all my numbers so far. That might be just a little bit too tiny. Let's try that again. Okay, I think they're still readable then. All right, I'm going to just start on a new line, 999, and then 64 times 2 is actually 128. So if I'm doubling it, the exponent, I'm doubling it to 128 this time. Where does that put me? Are we at 8? I think.
0.879797.
8797. 9.7 or 9.8 or something like that. Okay, cool. No longer in the 90s. If I double 128, that becomes 256. So what is going to give me if I do a power of 256?
It's 0.77404.3.
Thank you. All right, cool. Now we're in the 70s. 256 doubled is 512. We're almost stopping. We're going to do this step in one more, okay? 512. What do we get if I powered 512? What do you have, Monica?
0.599142.
Ooh, we're kind of far away now, aren't we? I mean, like we've kind of halved our value. I mean, it was close to 1, and now we're getting close to half. We'll do one more. 999, and then doubling 512 is 1024.
1.358971.
Okay. The reason I'm stopping here is, number one, hopefully at this point you can see that the numbers are now dropping consistently and by a chunk, a pretty good chunk each time. I'm getting farther and farther away from 1 every time I raise this power up, right? I'm definitely getting further away. And the other reason I want to stop here is because you can see that the power is only 1/10 of the way there. This is 1024, and I'm supposed to be going to 10,000, right? This is 1,024, and I'm supposed to be going to 10,000. I'm only 1/10-ish of the way there, and I'm already at 1/3, roughly, right? Like 0.3 repeating 1/3 of the value that I began at. So we're going to say a few things to our student that talks about what's happening here. So in general, we mentioned this first fact last time. Whenever you multiply by a number, let me say a positive number less than 1. Your product becomes smaller. And here, in this problem, in this problem, we're doing this namely multiplying by a value less than 1 10,000 times. Now, it's not the million or the trillion or the billion numbers that we looked at in that book, but 10,000 times is not trivial. If I gave you $10,000, you would gladly accept it, right? And you'd be very excited to do so. 10,000 is not nothing. And so you're multiplying and you're doing this 10,000 times, and every single time it's getting smaller. Eventually it starts getting smaller significantly, or by a significant amount. Does that make sense? All right.